welcome back. We're at day 2 of 4.5, and we're going to start applying solving rational equations into some story problems, learning how to solve work and rate problems. Okay, so first of all, we have this example here. Arthur and Cheyenne can paint a wall in 6 hours working together. If Cheyenne works twice as fast as Arthur, how long would it take for Cheyenne to paint a wall if she's working alone? So usually, we have our distance equals rate times time formula. And so instead of distance here, we're going to put work because it's a job, right? So it's kind of not we're going a distance, we're actually just completing a job. And so in this case, I have one whole job to do. That's usually what I put there, okay? When we're talking about time, if I put an X amount of time for Cheyenne, I'm going to put Arthur has 2X. So you have to be careful here because some people might want to put that since Cheyenne works twice as fast, they want to put 2X. You have to think about time. So if Cheyenne does it in an hour, Arthur's going to do it in 2 times as long. It's going to take him a longer time, so 2 times that time. Okay, so you have to be careful about that. So my rate, we want to find that. So my rate is going to equal distance divided by time. Here, so I'm going to take my distance, or my work, in this case, divided by time. So 1 over 2x, 1 over 2x. Okay, and so we also know that working together, so I'm going to put over here just together, it's the same job they're doing, and the time is going to take them is 6 hours. And the rate is going to be 1 job in 6 hours. So if you think about that, well, I have that 1 over 2x. This should be 1 over x. If your guys are in class, you catch me on this faster. In a video, it's hard to catch me faster. You're probably yelling at the computer screen. It's 1 over x, Mrs. Wise. There you go, okay? And then the rate here, so Arthur can do this in 1 over 2x. Cheyenne, 1 job in X hours, and together 1 job in 6 hours, okay? And so the way we write this now is the rates together, so 1 over 2x. If I add the rates together, that should give me the rates working, sorry, if I add the rates working alone, it should equal the rates together, okay? This should look familiar, right? Because we've been solving these rational equations here all along. And so what we're going to do is multiply our entire equation by our least common multiple. In this case, it's going to be 6. 2 goes into 6, so it's going to be 6x. It's going to be my least common multiple. Okay, that's my common denominator, is 6. So between the numbers 2 and 6, my common denominator is 6. And then for my variable x, that's my common denominator. So my LCM is 6x. Okay, so in this case here, I'm going to have 6x over 2x plus 6x over x equals 6x over 6. Okay, my x's get canceled out here, which I have red. My x's get canceled out there, my 6's get canceled out, and 2 goes into 6 3 times. So I end up here with 3 plus 6 equals x, which is 9 equals x. So up here, we know that Cheyenne can do this by herself in 9 hours, and it's going to take Arthur 2 times 9, which is 18 hours. Okay, so Cheyenne would paint the wall in 9 hours all by herself. Okay, all right, let's look at this one here. It takes 12 hours to fill a pool with 2 pipes, where the water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? So the same thing I'm going to put down here again. I'm going to put both pipes down here. Okay, I have one job they're all doing here. Okay, it takes 12 hours over here. That's 12 hours for both pipes. So my rate is going to be 1 over 12, 1 job in 12 hours, right? If my one pipe fills it in X hours, it's going to, the water in one pipe flows 3 times as fast. So the other one's going to take 3 times as long. Doesn't matter which one. It just says, what's one or the other. So my rate here is going to be 1 job in X hours. The other one's going to be 1 job in 3 times as long, 3x. Okay, so similar thing here. I'm going to add their individual rates together, 1 over x plus 1 over 3x, to get their total job of 1 over 12. Okay, so finding my LCM again between the numbers between 3 and 12, my common denominator there will be 12. And then my common denominator between x is going to be x. So my LCM here is going to be 12x. I'm going to multiply 12x on both sides. And so now I will have 12x over x plus 12x over 3x is going to equal 12x over 12. X's cancel out here and here. 12's cancel out there. 3 goes into 12 4 times. So we have a 12 plus 4 equals X. So 16 equals X. So that means that one pipe can fill this in 16 hours. The other one is going to be 16 times 3, which is 48 hours. So it says, how long will it take the slower pipe to fill the pool all by itself? That's going to be this guy. It's going to be 48 hours for that guy to fill up, right? So what's that? 2 days. That's a long time. Okay. All right. So now we're going to get into a rate problem here. So paddling with a current in a river, Jake traveled 16 miles. So even though he paddled upstream for an hour longer than the amount of time he paddled downstream, Jake can only travel 6 miles against the current. So in still water, if it's not moving, Jake paddles at a rate of 5 miles per hour. So what's the speed of the current in the river? Okay, so this one's interesting. So upstream, I'm able to only paddle 6 miles, right? Downstream, I'm able to go 16 miles, right? So my rate here, this is what it gets interesting. So my rate upstream, I can go 5 miles an hour in still water. And then since the current's pushing against me, I'm going to go 5 miles minus the current. 5 miles per hour minus whatever the current is pushing against me. Okay. So it might be, the current might be 2 miles per hour. So I can only go 3 miles per hour and so forth. Downstream, I can go 5 miles per hour plus whatever the current's giving me. So it might be giving me 2 more miles per hour. It might be giving me, 8 miles per hour. I don't know. Okay. That one's that one. So now my distance equals rate times time. My time here is going to be distance divided by my rate, right? So 6 over 5 minus C. 16 over 5 plus C. That's those guys. Okay. So now what we want to do is you want to relate this. So I kind of wrote this out here. So my 2 things that are equal here is the time that Jake paddled upriver plus 1 hour, because it took him another hour to paddle upriver, right? So he paddled an hour longer. And here he paddled upstream for an hour longer than the amount of time he paddled downstream. Okay. So that time is equal. So the time Jake paddled downstream is equal to the time he paddled upstream plus an additional hour. Okay. So that's what this is right here. Okay. So what I have here is my 16 over 5 plus C. That's my Jake's paddle rate in still water plus the current, and then his rate minus the current. And then we have, that he paddles upstream for 1 hour longer. So what I need to do here now is multiply both sides by my LCM, right? And so my LCM is 5 plus C times 5 minus C. So I'll just multiply this entire side by 5 plus C times 5 minus C. Okay. Over here, I'm going to multiply by 5 plus C times 5 minus C. Right? So now let's go down here. We're going to have up here, we're going to have 16 times 5 plus C times 5 minus C, all over 5 plus C, plus just 1 times 5 plus C times 5 minus C. Don't forget that 1. It's still a number. That's going to equal 6 times 5 plus C times 5 minus C, all over my 5 minus C. It's a lot of writing, right? So now what we can do is we can cancel out. We have this 5 plus C cancels out, my 5 minus C's cancel out, and we're left with just a big string of numbers here. So be careful on these. So 16 times 5 gives me 80. So we're going to go 80 minus 16C plus, we're going to just FOIL this guy. So it's 25 minus 5C plus 5C minus C squared equals, and I'm just going to distribute this guy here. So that's 30 plus 6C. Okay. Now I'm just going to start combining like terms. I can cancel those guys out. I have a negative C squared. I have a C term here, so minus 16C, and then plus 80. Or we have an 80 plus 25. Sorry about that. I almost missed that. It's going to be 105 there. Equals 30 plus 6C. Okay. So let's subtract this 30 over here and 6C. both sides, and we'll get -6 or -c squared minus, that's going to be 22c, and then plus 75. That all equals 0. Now, I don't want to have that -c squared there, so I want to multiply everything by -1. That will change the sign of all my terms. So c squared plus 22c minus 75 equals 0. So now I need factors of -75 to add to +22. So that will be c plus 25 times c minus 3. So c is going to be equal to -25 and 3. But we really can't have a rate of -25, right? My current is not going to be -25 miles per hour. It's going to be 3. So the rate of my current of my stream is going to be 3 miles per hour. So we go back over here. That is going to be my C. So in still water, there's 5 miles per hour. When it's trying to go upstream, it's going to be 2 miles per hour, and downstream will be 8 miles per hour. Okay, so that's how you do that one. Okay, so we have one more here. Rosa can jog 5 miles downhill. At the same time, it's going to take her to jog 3 miles uphill. She jogs down 4 miles per hour faster than she jogs uphill. Find her jogging rate each way. Okay, so her distance she's going to jog, she goes 5 miles downhill. Put that in there. And she jogs 3 miles uphill, right? And so her rate that she jogs downhill is 4 miles per hour faster than she jogs uphill. So if we say we're going to go, the rate is downhill R, her rate going uphill is going to be the rate minus 4. It's going to be slower, right? My rate minus 4 miles per hour. So then my time is going to be distance divided by rate. So 3 divided by R minus 4 and 5 divided by R. Now I could have put R here and then put R plus 4 there because it's going to be faster going downhill. That would be okay too. It would be the same thing. Okay. All right. So now we know that find her jogging rate each way. So we know that her times are the same right there. Okay. So the same time it takes. So this is a key word right here. So we know our times are the same. So we know that 3 over R minus 4 equals 5 over R. And that makes a nice rate. That's a proportion, right? Just one fraction equals the other. So I can actually just cross multiply. So 3 times R equals 5 times R minus 4. So 3R equals 5R minus 20. I can subtract my 5R. Whoops, there we go. Negative 2R, gracious, equals negative 20. So my rate equals a positive 10. So it looks like she goes 10 miles per hour downhill, and then 10 minus R will be 6 miles per hour uphill. Okay? All right, so that's how you set those guys up. All right? And you guys will have an Excel for day 2, and that will be due on Monday. And I will see you guys all next week. Take care. Bye-bye.